in that comparison, you must have seen this. Force will be replaced by torque, right? Now, what is this torque? Torque is also known as recording on it. Torque is also known as moment of force. Okay. Always remember, torque is equal to Rf sine theta. This is only magnitude of torque. In vector form, we can write torque is equal to R cross F. See, we need torque to rotate an object. Suppose we have a rod which is hinged. If you want to rotate this rod, which force can rotate this rod? Can F1 rotate this rod? Which force can rotate this rod? F1 or F2?
F2.
Correct. F2 can rotate this rod. Okay. That's why when you will write value of torque, you will write, suppose this distance is L. Okay. So torque is that physical quantity which can make any body rotate, right? So F1 is not able to rotate this rod, but F2 is able to rotate. So torque generated due to F2 is given by F2 into L. Now what is L? L is perpendicular distance. L is perpendicular distance between line of action of force and axis of rotation. Okay, this is L. Now you see that if we make line of F2 big, this is line of action of F2. This is line of action of F2. And what is L? L is making angle 90 degree with it, right? That's why while writing torque, we take perpendicular distance. Now you will say, sir, you just told us the formula is Rf sine theta. So from where we got this sine theta? Where theta is the angle between force and the position vector. Let's see. Let's try to understand it here. What sine theta is doing here? This diagram will explain. Again, assume this is a rod. Okay, it is hinged, it is free to rotate about this point. This rod is free to rotate about this point, and suppose an external force is acting on the rod like this. This force is acting on the rod at an angle theta with the horizontal. Suppose this force F is acting on the rod, as you can see, right? Can we make two components of this force? One component like this. This component will be equal to Noor F sine theta.
F sine.
And this component will be F cos theta. Now tell me, which component will make rod rotate? Which component can rotate? Correct. F sine theta can rotate the rod. That's why now we will write torque is equal to F F cos theta or F sine theta? F sine theta, because F sine theta is rotating the rod into L. From here we got torque is equal to L into F sine theta. Okay. Now let's see vector form of this. This is x-axis, this is y-axis, and this is x-axis. Suppose this is origin, and suppose this is a point. Let's say x comma y. Now let's assume a force F vector is acting on it. This is a force F vector acting on it. Okay, and position vector of this point A. Suppose this point is point A. What is position vector of this point? Can you tell me? Can you tell me what is OA vector? OA vector will be equal to xi plus yj. Now, in vector form, we can write torque because of F about origin, torque because of F about origin. In vector form, we'll say OA cross F because here OA is performing role of R vector. Understood? So we can write, hopefully everyone remember how to expand cross product, mod of OA, mod of F, sine theta. Like this. Now let's solve, now let's take few easy numericals based on the torque. Torque is also known as moment of force. Give me 1 minute. Let's start with a very easy question, very basic question. This is our first question. Suppose this is hinge. About this point is free to rotate. About this point rod is free to rotate. This is our rod. This is our rod. This is hinge. Okay. And a lot of forces are acting on it like this. One force at a distance of 0.5 meter. At a distance of 0.5 meter, one force is acting in this direction, 45 degree. Here one force is acting. This is F5 and its value is 20 Newton. Okay, and it is acting at an angle of 45 degree. Okay, the total length of this rod is 1 meter. Lot of, what? There is another force.
सर थीटा
Theta 45 degree.
सर थीटा में ले लो मतलब 45 नहीं वेरिएबल क्वेश्चन के लिए
अगले क्वेश्चन में बेटा पहला इतना कठिन नहीं लेंगे. Another force F2 is acting in this direction. This is F2. F2 is also 20 Newton. It is acting at an angle of 30 degree. And another force is there. That is F3. F3 is acting in this direction. Value of F3 is also 20 Newton. Another force is acting on it. That is F4. Another force is acting. This is F4. And F4 is making an angle 30 degree with the horizontal in this direction. Okay. Now what is your task? Hopefully you can see a lot of forces F1, F2, F3, F4, F5. Now my question number one is what is magnitude of torque exerted by F1 on the door? What is magnitude of torque by F1?
0.
0.
0. Correct. Correct. 100% correct. Rajul, Apple Pencil battery is low. You find torque due to all the forces one by one. In 5 seconds, 10 seconds, I will charge my Apple Pencil. Don't worry. Meanwhile, I will answer question number one. Find torque on rod ड्यू टू, उसी में है शायद, डिब्बी में ही है, ड्यू टू, मैंने रख दिया था वापस. फाइंड टॉर्क ऑन द रॉड ड्यू टू F1. Question 2 says find torque due to F2. Question 3 says find torque due to F3. Okay, we solve this. Noor, take component of F4 and F2 and F5 and look at only that particular force due to which you want to find torque. Ignore all other forces. Done?
Sir,
What is
F4 is how much?
F4 is 20 Newton. Find torque due to all the forces. Find torque due to all the forces. F4 is 20 Newton. राजुल हो गया होगा ना? वो तो आधा घंटा चलती है एक बार चार्ज. Okay, now see, I will explain you why torque due to F1 is 0. What is the angle between this 1 meter distance and F1? See, let's make rod. This is rod. Okay, it is hinged point, and F1 is acting in this direction. Okay, Noor? F1 is acting in this
Yes,
direction, and practically you know that this F1 cannot make this rod rotate. Now answer my simple question: what is angle between this 1 meter distance and force?
0.
What is angle between 0 degree? That's why in the formula of torque you write RF sin theta, and theta is the angle between R and F. In our case, angle became 0. That's why we are getting numerically torque 0. Okay. Now let's write second question. Look at only F2. Let's draw only F2. Solve one by one. F2 is acting like this at an angle of 30 degree. Okay, Noor? 20 Newton at an angle of 30 degree it is acting. Okay. Now tell me which component of this force, which component of F2 can make this rod rotate? 20 cos 30
20
20
sin 60.
or 20 sin 30. 20 sin 30, it will be sin 30. Which component of force will make rod rotate? Simple, this component, right? Because torque is force into perpendicular distance. Force this, let's take this force, and perpendicular distance is 1 meter. And torque due to 20 cos 30 will be 0. Okay, Noor? Torque due
Yes,
to
sir.
20 cos 30 will be 0. Okay, Charan? Apart? So the torque
Yes,
due
sir.
to F2, this is question number 2 solution. 20 sine 30 is 1 by 2 into 1. You get 10 Newton meter. Okay. Now let's talk about torque due to, we found torque due to F2. Torque due to F3 is very easy.
20 Newton.
F3 is,
Newton per
20
F3 is
Newton.
already perpendicular. Force into displacement, 20 into 1. You got the answer, right? And now hopefully you can find torque due to F4 and F5 by your own, right? You want any help in torque due to F5, or we can move towards next question? We can move towards next question.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay.
Yes, sir.
Yes,
Tell me, what are the necessary conditions for equilibrium? What are the
Force
necessary
0
conditions?
or net force 0 or net torque 0.
Correct. Write note. Condition for equilibrium. Of a body. First, net force must be 0. Net force must be 0. For net force to be 0, net horizontal force must be 0 and net vertical force must be 0. Right? And the second situation is net torque must be 0. Okay, net torque will be 0 when there is no net torque, when clockwise direction torque is equal to anti-clockwise direction torque.
Anti-clockwise direction.
Right? So there are two conditions required for equilibrium. Net force and net torque both must be 0. Now, based on this information, I have a very good question for you all. Be ready, okay? Stay attentive. My next question says that a force is applied to the end of 2 meter long uniform board weighing 50 Newton. See this? We have a long board type. Suppose this is board. Okay. Applied to the end of a 2 meter long. Its length is 2 meter long. Its weight is 50 Newton. Okay, according to question, a force is acting on it like this. A force is acting on it at an angle of 30 degree. At an angle of 30 degree with the horizontal F. 30 degree. A force is applied to the end of a 2 meter long uniform board weighing 50 Newton in order to keep it horizontal. While it pushes against a wall at the left, the angle force make with the board is 30 degree, the direction shown. The applied forces. ठीक है, इसको
50 Newton.
F की value निकाल. What is value of F?
50 Newton.
Can you tell me? 50 Newton, that's it. Okay. I think you are correct, but to make next questions very easy, I want to explain this properly. See this. Now let's make two component of force. Let's make two component of force. One component is this. This is F sine 30. And one component is this direction. This is F cos 30. Right? You understood? Can you see two components? Right?
Yes, sir.
Now weight will act as center of mass at a distance of 1 meter. Now tell me where this 50 Newton want to rotate this rod, clockwise or anti-clockwise? 50 Newton.
And
How 50 Newton want? 50
Anti.
Newton
anti-clockwise.
want to rotate rod clockwise. Clockwise. See this. This is hinge point. About this point it is going to move. This is hinge. About this point it is free to rotate. How 50 Newton will rotate? Like this. 50 Newton will rotate it like this. Okay. And how F sine theta, and this is clockwise direction. Okay. And how F sine 30 want to rotate it? How F sine 30
Anti-clockwise.
want to rotate? Correct. F sine 30 want to rotate it anti-clockwise, and F cos theta cannot rotate it. So now let's write net torque equation first. So let's find clockwise torque, force into perpendicular distance, that is 1 meter. So we got 50 Newton meter. Any doubt in this, Noor? Chiran? Chinmay? Nisagra? Okay. Suppose this is equation 1. Now let's find anti-clockwise torque. Anti-clockwise torque is due to F sine 30 only. Do you agree? F sine 30 into perpendicular distance. What is perpendicular distance? That is 2. This is equation 2. Now for equilibrium of rod, clockwise torque must be equal to anti-clockwise torque. 50 is equal to F sine 30 into 2. These two must be equal. So 50 is equal to F into 1 by 2 into 2, which Ankita solved very fast. But I have one more doubt, Ankita, in this. Can you tell me force applied by the hinge on the rod? In previous question, find force applied by the hinge on the rod.
So 25 root
In-
3.
In previous question,
So 25 root
find
3.
correct. Force applied by hinge on the rod. See, net force must be 0, right? So let's make its diagram again. Let's make diagram of rod again. This is rod. This is our rod. It is hinged from this point. A force F is acting at an angle of 30 degree like this. Recently we got value of F. This will be F sine 30 and this will be F cos 30. Downward, how much? 50 Newton. For rotational equilibrium, net force must be 0, right? And just now we got value of F as 50. We got value of F as 50. See, in vertical direction, how much force is present? 50 sine 30, that is 25 Newton, right? Okay, Noor? Vertically
Yes,
upward,
sir.
how much force is available? Vertically upward, how much force is available? Only 25. But how much is required? How much is required?
50.
50. Means that other 25 Newton is applied by who? Other 25 Newton is applied by
F
hinge.
cos 30.
No, hinge will apply upward. Okay, hinge will also apply a force. So force due to hinge is 25 Newton upward. And so now we made net vertical force 0, right? 25 plus 25 is equal to 50. We made net force 0 along Y. Now, see, F cos 30 is acting at the left. You understand that? F cos 30 is acting at the left, where F is 50, cos 30 is root 3 by 2. So 25 root 3 is acting on the left hand side. So how much force must act on the right hand side so that net horizontal force becomes 0, Noor? Same. You want to make net horizontal force also 0, na? So if left hand side you have 25 root 3 Newton force, right hand side force must be also equal to 25 root 3. You understand that? You understand that?
Yes, sir.
Now, the force applied by the hinge on the rod will be resultant of these two. Will be resultant of 25 Newton and 25 3 Newton. This is the net force by the hinge on the rod. Do you agree with this? Black color force. So net force by hinge on the rod, net force by hinge on the rod will be 25 square plus 25 root 3 square. You will get 50 Newton. So you all are wrong. Net force applied by the hinge on the rod is 50 Newton. आता न जाता भारत माता. Okay. Now let's solve another question. Hopefully you understood how to handle such questions. Now next question says that we have a rod. A uniform rod has weight 40 Newton and has length 1 meter. A uniform rod has weight 40 Newton. बीचों बीच लगा रहा हूं देखो. At the center I'll apply weight 40 Newton and length 1 meter. Boys, there is a string also. There is a string. This is a string. Now see, the question is, what is force in the string? What is force in the string? Can you tell me what is force in the string?
Sir, 20 Newton.
20
20
Newton.
Newton.
You are correct. Now you all are correct. Suppose force on the string is T. Suppose force on the string is T. Tension. Tension is also a type of force. Now tension want to rotate this rod anti-clockwise. And 40 Newton want to rotate this rod clockwise. Agree, Chirag? Apar agree? Anushka? Anujna agree with this? Okay. This is 0.5. Clockwise torque must be equal to anti-clockwise torque. So 40 into 0.5. Force into perpendicular distance. This is force and this is perpendicular distance. Force into perpendicular distance. So this will make clockwise torque. This is clockwise torque. Clockwise torque must be equal to anti-clockwise torque, and anti-clockwise torque is T into 1. Force into perpendicular distance. See, this is perpendicular. And this is torque. When you solve this, you'll get T is equal to 20 Newton. Understood? Now, in previous question, in this question, find force applied by the hinge. In previous question, find net force applied by hinge. Can you do it? Very easy.
20 Newton
So
upward.
20 Newton.
20 Newton. Net downward force and net upward force must be 0. Suppose hinge is applying F force here. There is no horizontal force in this case. So downward force is 40. Tension is 20 Newton. So this side you need 20 Newton. Okay. So hinge will apply 20 Newton force upward. Upward to make net vertical force 0. Understood? Nisagar, mute yourself, please. Now, let's see how much you understood from an easy question. In this question, your task is to find value of small m. the equilibrium of system shown, find value of small m. I'm drawing system. For equilibrium of system shown, find value of small m. System is like this. This is a support. This distance is L. There we have a 12 kg ball. There we have a M at a distance L,
Nadu.
and we have a 3 kg at a distance 3L by 2 from here.
ಯಾರು
Find value
ಏನ್
of
ಮಾಡ್ತಾಳೆ
M. Nisagra, keep yourself mute, please. Nisagra, your mic is not muted, beta. Okay, thank you, Nisagra. Find value of small m for equilibrium of system. Can you do it? Anyone? Any answer?
15.
15. Not in the option.
7.5.
7.5 is also not there in the option.
सर आप फिर पहले ऑप्शन बता दो ना.
नहीं, आंसर बता, मारूंगा चाटा.
सर 24/5.
24/5 अप्रोक्स कितना आ रहा है?
सर 5.
24/5 5 से कम आ रहा है ना?
हाँ सर 5 से कम है,
there.
अप्रोक्स 5 है.
तो अपार 4.5 है ऑप्शन में.
हाँ सर 4.5 आ रहा है.
ठीक है, apar is saying 4.5 and it is there in the option. Now let's start solving this question. Represent all the forces. So here mg is acting and this mg is equal to 120 Newton. Agree? And let's take torque about this point. Okay, it is hinged. This point is support. So let's take net torque about this support. Here we'll get mg. We don't know value of m. Here we'll get 3 kg means 30 Newton, right? Now for equilibrium, net torque must be 0, right? For equilibrium of system, net torque must be 0. So net clockwise torque must be equal to net anti-clockwise torque. 120 Newton. 120 Newton will try to rotate it anti-clockwise direction, right? And mg and 30 Newton will try to make it rotate clockwise direction. Agree? Now let's make and net torque 0. 120 into L gives us clockwise torque. Okay? And mg into
नहीं
L
सर 3.4 आ रहा है.
30 into
3.4.
this is L by 3L by 2. So this total distance is
5L by 2.
into 5L by 2. This gives us clockwise torque. Okay, so total clockwise torque. This is total clockwise torque. Sorry, anti-clockwise torque. Equated with the clockwise torque. Now you can take L common and cancel. You can take L common and cancel. Now solve this. 120 is equal to 10 into M plus 75. So you will get 75. 120 minus 75 by 10 is your answer. What you will get? 120 minus 75 कितना होता है? You are getting 4.5 kg. You could not solve a simple question. See this. Answer is 4.5 kg. Accurate answer. एक बार और बेइज्जती करवाओगे? बोलो अपार.
हाँ सर
तैयार?
तैयार है. अच्छा क्वेश्चन देना.
अच्छा दे रहे हैं. Be ready for next question.
नहीं
Any doubt in this
मतलब
question?
अगली बार बेइज्जती हो पाए ताकि.
हाँ ठीक है. Any doubt in this question, Anujna? Noor?
No, sir.
Okay. Now next question is easy. Let's see you can get answer or not. A rod AB of mass small m. A rod AB of mass small m is hung by two ideal threads. By two ideal threads. Find ratio of tension in the two threads. This is rod. This is rod AB of mass m. This is T1. This is T2. Don't say it is 1. First, look at the question. This complete distance is L by 2. Okay, but there is a small point mass, small m capped at a distance L by 4 from the center. Okay, now find T1 upon T2.